Well, I'm actually working on, I would say biosensors, but I'm using microfluidics as the basic tools to actually enable the biosensing. I'm an engineer by background, so I like to build things, and when I was a kid I was kind of taking things apart and trying to put them back together again. Never worked, but I'm also fascinated by biology. And what I'm trying to do is kind of apply my engineering skills to solve some biological problems. We are trying to diagnose people with various diseases. We're trying to help understand some diseases. We also try to look at drug discovery. It's a very broad field of research.
I'm working on developing microfluidic devices for assessing how susceptible tumours are to drugs, but in a patient-specific manner, and how we can develop systems to optimise treatment plans for them. I essentially print like master moulds that I then pour polymer into, and these polymers are designed specifically so that we can fabricate certain devices. What I'm looking at is capturing tumour spheroids within a single well so that we can then perform assays on them and assess like how do these individual spheroids respond differently.
Most of the time we use polymers to make these devices because you need to replicate them. You need to just kind of, it's not the one device in the lab. You want to have that being used by clinicians and so on. So we have, on the prototyping scale, we do work with some elastomers, some fairly simple polymers to work with, but then we look also at the other end of the spectrum where we work with injection molding.
Rather than looking at developing new materials, we're looking at how can we optimise the protocols and the way that we fabricate the current things that we have. One of the standard kind of materials that we use, it's really good for a lot of applications. It's cheap, but if you're looking at, say, testing drugs, it absorbs a lot of drugs, so you have to look at possibly alternative materials, but that is a little bit further down the line.
We're trying to grow organs on a small chip to try to look at, perhaps drug discovery, or looking at a blood-brain barrier to try to see how the drugs can go across the barrier. And it's all made on a small chip. You're closer to the physiological conditions because you have the flows, you're gonna have communications between different organs or tissues, and you can start to have really interesting interactions and insights into a whole lot of biological processes. So one thing which is great about Warwick is that you have got these very interesting cross-disciplinary interactions. I'm a good example because I'm in WMG, so manufacturing group, having a lab here in the medical school. I interact with people in physics, in life sciences, in chemistry, in engineering. So there are, the summer studentship, the RSS scheme, WMG internship as well, summer internship. And then we go via the various CDTs around the campus to try to get students to work with us. And of course, we also have the department students that do come via, the official routes.